Good evening everybody. Welcome to the online classes. Actually, the previous session I have started mensuration. So today discuss about the remaining part. This is a mensuration part 2 class. So part 1 class discuss formulas. 4 internal formulas is completed: cube, cuboid, and prism, next cylinder. Now discuss about that first one is that means fifth one, pyramid. Guys, first you have observed that okay, it is a pyramid model. How do you define this pyramid? That's the pyramid name is dependent upon base. What is the base is given, that is the decide of the name of the pyramid. It is not a prism. Why it is not a prism? Just you observe base face and the top face. These two are not same, not parallel. In the top face is form of one of the dot, it's like that vertex. Is a base face. These two are the different, so it is called a pyramid. You draw the one line from the vertices to the base. That line is perpendicular of the base. That type of pyramid is a right pyramid. Right pyramid. Okay. So here this one is a height considered is h. Pyramid to the base of one point is join it is form one of the line that is called a slant height L. Slant height L. Now lateral surface area of pyramid. Lateral surface of pyramid. See, it is depends on the first base, perimeter of the base, but here only one base is there. The base and top is not same. That's why I am write half of the perimeter of the base, into slant height. Slant height. Okay guys, once again repeated, it is not a prism. First that point keep your mind. What is the difference between pyramid and prism? Prism base and surface, top surface are both are the same. But in this case, base and top is different. The top is form of the vertex. Why? Because this all edges are meet one point. That point is called a vertices. So base and top are different in this case. So it is not a prism. It is called a base. This name is depends on the base of the pyramid. So this is a height. You consider this height. That means you draw the one line from the vertices to the midpoint of the base. So this is a considered height. Now join vertices and one point of the base. It is a slant height. That is take up that L. Now I write the lateral surface area of the pyramid. How? Half of the perimeter of the base into slant height. Next one, total surface area of pyramid. Total surface area of pyramid. So it is depends on the lateral surface area. LSA plus area of the base. Area of the base. Okay. Next, volume. Volume of the pyramid. Volume of the pyramid. It is a 1/3 area of the volume of prism. 1/3 volume of the prism. Or 1/3 area of the base into height. Area of the base into height. Okay guys, 1/3 area of the base into height. Area of the base into height. This is a lattice surface of the, it's a cone like this. This is a cone shape. So here base is a circular circle. Circular circle. Here form one of the vertex, and you draw the one line to the base. So it's made the perpendicular. That is considered the height of the cone, and join this one. It's a radius. Why? It is what the shape of the base. Circular circle is a center. You join one point to the circle. It's form of the radius. Next one, it is a slant height. The slant height represents the small l. How to define the slant height? Join vertex and the circumference of the circle of one point. Its form the line is called a slant height. Once again, it is a vertex. Here take it that one point on circumference of the circle is join it. It's a form of one line. That line is called a slant height. How to define that cone? As vertex and with the ending of the base circle and with the curved surface area, it is called a cone. Now see here how to find out the slant height. L square is equal to h square plus r square. Why? Because here form of one of the triangle. See, ABC is a triangle. What type of this triangle? ABC is a right angle triangle. Right angle triangle. So from the figure, its form of the right angle triangle. This is a height. This is a radius. This is a L. Immediately apply that Pythagoras theorem. Hypotenuse square is equal to side square plus side square. That's why I write that L square is equal to h square plus r square. Suppose you find out the h. So h square is equal to L square minus r square. R square is equal to L square minus h square. Okay guys. Now lateral surface area of the cone. Lateral surface area of the cone. Yes, here the perimeter of the circle, and the slant height. But wait, the cone is formation from sector. You know the sector? You take up this one. Yes. This is circle. It is a center. You have selected 2 points on the circle A, B. Join OA and OB. It's the radius of the circles. The cut it according to that radius. Its form of that sectors. 2 sectors is formed. One is a minor sector, another is a major sector. This is called length of the arc. This is called length of the arc. Length of the arc. That is represent small l. This is radius is r. Guys, it is like that cone. So this is this sector is just hold it. Just overlap. This one don't overlap. That's just the 2 edges of join it. These two OA and OB just your join it. Don't overlap. So this sector is immediately changed. That's one cone form. So already you know that what you know that area of that sector, general formula, area of the sector off into LR. Off into LR. L means length of the arc. In this L its sector is converted in the core, the length of arc is converted in the circumference of the circle. See this one. This is joint. This one is joint. So this is a convert. So the slant height is converted here. See. Please see. So off into perimeter L into R. So off into L means perimeter of circle into radius. That's radius not taking that slant height. Slant height. So off into perimeter of the circle general formula 2 pi r. 2 pi r into slant height formula L. So 2 cancel pi r L. It is a lateral surface area of the core. Lateral surface area of the core. Next one. Total surface area of the core. Total surface area of the core. That means you take the first area of the lateral surface area plus area of the base. Area of the base. Area of the base. What is the area of the? What is the shape of the base? Circle. So you write the area of the circle formula. Lateral surface area of the core formula, already get it, that is pi RL. Pi RL plus pi R square. Here two terms are formed, and the two terms are which one is the common? Pi R is common. Here the first term is what is the remaining L. In the second one is pi R of L plus R. Okay guys, pi R of L plus R. It is a total surface area of the core. Next one, volume of the core. Volume of the core. Weight. It is actually 1/3 area of cylinder. Area of the cylinder. 1/3 of what? Sorry, volume of the cylinder. 1/3 of volume of the cylinder, general formula pi r square h. So 1/3 pi r square h. See here, I do one experiment. See. I take it that one is a hollow cylinder and a hollow core. These two are the same base and the same radius and same height. Okay, now I take it this clear. See, first I take some water in a glass. Just the water is poured into the core. Yes. Next one is pour into that water in cylinder. Check it. This one I do 3 times. Right. Yes. So it's a completely fulfill of the water. How many times is complete this one? 3 times is complete of this one. So volume of cone is 1/3 of this volume of cylinder. That's why I am writing volume of the cone is equal to 1/3 of volume of the cylinder. So 1/3 of pi r square h. Okay guys. So what is the general examples of the core? What is the general examples of the core? Example 1. Ice cream. Ice cream is a cone model. Ice cream is a cone model. Next one. Buffon's cap. Buffon's cap. Buffon's cap. The third one, paddy. Paddy or sand, hip. Okay, these are the examples of cone. Ice cream, buffoon's cap, paddy and sandy hips. Fourth one is a circular tent. Circular tent. These are the examples of general examples of the cone. Here one bit is there. What is the ratio of volumes of cone and cylinder? Cone and cylinder 1:3. That's very important bit. What is the ratio of volumes of cone and cylinder? 1:3. Okay. Next one. Suppose this cone vertically cross section. So the plate, what type of the shape is formed? Triangle shape is formed. Once again, this cone is vertically cut it. So inside the plate, what shape of is formed? It's a triangle shape is formed. So cube, cuboid, pyramid, prism, cylinder, cone completed. The last but one, that is a seventh one. That name is a sphere. Sphere. So, see this picture. It is a center. Yes. This one is a sphere. It is a geometrical object. How to define the sphere? The set of points are equidistant from a fixed point on plane. The set of points are equidistant from a fixed point on the plane. So that is a definition of the sphere. So the equidistance, you have taken that means equidistance that can take the radius of the sphere. Radius of the sphere. Radius of the sphere. Next one, fixed point. This one is a fixed point that is called a center of the radius. Center of the radius. So this one is sphere. What is the lateral surface area of the sphere? Lateral surface area of the sphere formula pi r 4 pi r square. 4 pi r square. Here generally 4 circles you join. One alternate one, its form of the sphere form. So each one area of the circle formula pi r square. So 4 circles you are joined one by one, its form of the sphere. So that is a 4 pi r square. 4 pi r square. So in this case, in the sphere case, lateral surface area and total surface area or surface area all are the same formula. So this one you write the total surface area, the same formula you write the surface area. So any one, that formula is 4 pi r square. Next one, volume of sphere. Volume of sphere is 4 by 3 pi r square, pi r cube. 4 by 3 pi r cube. That is a volume of the sphere. That is a volume of the sphere. So last one, hemisphere. 8th one, hemisphere. Yes. See, this is called hemisphere. How to define the hemisphere? Just take the one sphere. You draw the one line to the plane. The line is the plane is the plane. The line is the travel to center of the sphere. The plane is divided into 2 parts. Each one part is equal, it is called a hemisphere. It is called a hemisphere, like this one. It is the half of the hemisphere. So half of the sphere. Now see, lateral surface area of the hemisphere. Lateral surface area of the hemisphere 2 pi r square. Why? It is half of the sphere. Half of them means how many circles are there in the sphere? 4 circles generally are considered. But hemisphere, how many circles are considered? 2 circles. Half is 2. So half into 4 pi r square, you get that 2 pi r square. But here total surface is also there. That formula is different. PSA is equal to, this surface area is equal to 2 pi r. And one more surface area adding, it is what the shape of the surface area? Circle. So lateral surface area of the hemisphere plus surface area of the top. Surface area of the top. That means area of the top. So what is the circle? What the shape is one? Circle. So this is a formula 2 pi r square plus this area of the circle formula pi r square. 2 pi r square plus 1 pi r square, 3 pi r square. This is the total surface area of the hemisphere. Volume of the hemisphere. Volume of the hemisphere. It is a half of the volume of the sphere. Half of the volume of the sphere. As half of the volume of the sphere 4 by 3 pi r cube. This cancel 1, 2 times 2 by 3 pi r cube. So volume of the hemisphere is formula 2 by 3 pi r cube. Okay, guys, what is the examples of the sphere? The general examples: volleyball, football, and globe. These are all the examples of general examples of the sphere. So the formula session, the first one subtopic is formula session is completed. Once remember that's total all formulas in this case. Wait, I completed the first subtopic of mensuration, formulas. So remaining 4 topics are depends on the formulas. That's most important. Once remember the total all formulas, your textbook. So surface areas and volumes of different solids. So serial number, name of the solid, figure, lateral surface area, LSA means lateral surface area, and I have taken that place curved surface area. It's no problem. Test TSA means total surface area and volume. So the first one, cuboid, is like this. 3 dimensions is there. This is a L, this is a breadth, this is a height. This one is a L, this is a breadth, this one is a height. So what is the lateral surface area of the cuboid? What is the lateral surface area of the cuboid? So 2h of L plus B. Second one, cube, is a cube shape. In this case, it is also 3 dimensions. In the 3 dimensions means L, B, H are equal. All sides are equal. So the volume, lateral surface area of the cube formula 4a square. Total surface area of the cube formula 6a square. Volume of the cube formula a cube. So lateral surface area of the cube formula 4a square. Total surface area of the cube formula 6a square. Volume of the cube formula a square. Next one, right prism. It's a triangle prism. Why? It's a base of the triangle shape. Base of the triangle shape. So right prism. What is the lateral surface of the right prism? Perimeter of the base into height. Perimeter of the base. Suppose you are considering this one is a base. Is what the shape of this base? Triangle shape. So perimeter of the base into height. Okay, guys. Next one, total surface area. Total surface is definitely depends on the lateral surface area plus top and base. So lateral surface area plus 2 into area of the end surfaces. Next one, volume of the right prism. What is the general form of the volume? Area into height. Area of the base, A for here, capital A for area of the base into height. Next, fourth one, regular circular cylinder. Regular circular cylinder. It is C. In the cylinder, this one is a consider the height. It is a axis of the cylinder. It's made 90 degrees with that cylinder, so it's a regular circular cylinder or right circular cylinder. Both are the same. So that lattice surface of the cylinder is 2 pi RH. Why? Because it is a perimeter into height. So 2 pi RH. Next one, total surface area of the cylinder 2 pi R of R plus H. Next one, volume of the cylinder pi R square H. What is the general examples of the cylinder? Measuring jar. Next one, oil drum. Next one, road roller. Next one, iron pillar. These are the general examples of the right circular cylinder. Next one, right pyramid. Right pyramid. In the pyramid, it is straight. Dot line is a direct height, that's when you take it the H. This is a slant height, you are taking the L. So how to write the lattice surface area of the right pyramid? Off into perimeter of the base into slant height. Off into perimeter of base into slant height. Next one, total surface area of the right pyramid, lattice surface area plus area of the base. Lattice surface area plus area of the base. Next one, volume of the right pyramid, 1/3 area of the base into height. 1/3 area of the base into height. Next one, right circular cone. Right circular cone. This one, see, this is one of the cone model. It is a perpendicular height. That's when you take it the H. This one you take it, this is a radius. Why? It is a what the shape of the base, circular shape. That's when you take it that R. This is a slant height. That's what represented by small l. So pi R L. What is the right circular cone lattice surface area formula? Pi R L. How to find out the L? L square is equal to H square plus R square. Next one, total surface area of the right circular cone, pi R L, pi R of L plus R. Pi R of L plus R. What is the volume of the right circular cone? 1/3 pi R square H. It is link of that cylinder. So 1/3 of the volume of the cylinder equal to volume of the cone. Here one important bit is there. What is the ratio of cone and cylinder? Volume of the cones and cylinder is a 1:3. 1:3. Next one, sphere. Next one is a sphere. It's like this. So, lattice surface of the sphere formula 4 pi R square, and total surface of the sphere formula 4 pi R square. Volume of the sphere formula 4/3 pi R cube. Next one, hemisphere is a model of the hemisphere. Lattice surface of the hemisphere formula 2 pi R square. Total surface of the hemisphere formula 3 pi R square. Volume of hemisphere formula 2/3 pi R cube. Okay guys, next one. Here I give some examples of solids of combinations. See, it's important in the according to public examination. This one given the one question in this small topic. See, some solids figures and their combination of shapes of the solids. Name of the solid, figure, shape. First one, tanker. Tanker. See, this is a cylinder shape is there, and but ends are hemispheres are there. So it is a shape is combination of the cylinders with the two hemispherical ends. Next one, toy or water drop. Toy or water drop. You observe toy and water drop is like this one. Here the combination of that is a combination of that core and hemisphere. See, it is shape is the combination of core and hemisphere. Guys, first you are observe. That's what he clear it. Box is a, see this box is a cuboid and half of the cylinder is joined. So it is a shape is combination of cuboid. See, length z, breadth y, height x. So three measurements are there. So it is a cuboid and is joined one more solid is there, that is a half of the cylinder. Half of the cylinder. This dot, see the shaded face totally required, that is a half of the cylinder. Next one, sharp pencil. Just imagination of sharp pencil, guys. So this like this. In the sharp pencils is a actually three combinations, three solid combinations. This is a cylinder. The middle part is a cylinder portion. Upper portion is a cone portion, and down portion is a hemisphere portion. So in the middle part is a cylinder. That endings of joint, one is cone, another one is a hemisphere, right? It is a shape is a cylinder with a cone at one end and a hemisphere at the other end. One end is joint cone, another end is joint hemisphere. Okay, next one, funnel. So the funnel see like this. What you guess it? See here, cone. Just guess it. Just this is a cone, reverse cone, and the downside some vessel there, that is a cylinder shape. Okay, so it is shape is a combination of cone and cylinder. Next one, capsule. You know, that's one capsule like this. This and this one both are like the simply same, but the title is different. It's a tanker, it's a capsule. Here the combination of the ends with the hemisphere and the middle part is a cylinder. So it is shape is cylinder with the two hemisphere ends. Next one, rocket. Next one, it's rocket. See this rocket is combination of its upper portion is a cone and down portion is a cylinder. So its shape is a combination of the cone and a cylinder. Yes, actually the public examination oriented in this chart. In this chart, one question is there. Draw the rocket. So immediately find out how many combinations are, how many solid combinations are there. So it is a two combinations. One is a cone solid combination, another one is a cylinder combination. It's form one of the solid. So you take it the water drop. Water drop means it's a combination of the core and the hemisphere. It's form one of the solid. That's one. Okay, guys. So in this session, I have completed first subtopic of the mensuration, that is the formulas and combinations of the solids. These two are important. Next one class, remaining subtopics discuss. Remaining 4 subtopics are there. They definitely discuss the 4 subtopics. Okay, guys. So the 4 subtopics are depends on that these formulas. Now you immediately learn that formulas. That formulas keep your mind. Next session will be discussed about the remaining topic.